for sure. There'll be 3 or 4 things on the screen tomorrow. Now, this is not the only problem. We went over a bunch already, but each problem or each test I have a big problem. I'm sure you're used to that by now. That attacks multiple chapters from the AP book. So this is that large question. So it's giving you percent by mass. We did a practice problem like this. You may or may not remember. It gives you density. All right? It asks for mole fraction, molality, molarity, net ionic, and then some piv nerd stuff. Okay? I would like to give you 13 minutes and see how far you can get into this problem. If you're stuck, remember, you can choose a volume or actually on this one, choose a mass and turn the percentages into the grams of each piece you have and go from there. Everything is still there except for the chlorine ion. So it's your only spectator ion. But probably no one did that. And E I haven't calculated even myself yet. So let's work these through. We got a good solid 20 minutes. Won't take that long. There is a bunch of ways to do this. You don't have to do it my way. I just do things the same way I've always done them. As I walked around, I saw 2 or 3 different ways to do the same thing, and some of them probably made more sense than what I'm going to do, but whatever. So mole fraction, if I have 1,000 grams of this, it says mass here, so I stuck with grams. Then I have 400 grams of HCl. I'm going to take and divide that by 36.5 and get a number. And I have 600 grams of H2O. Whoops. I'm going to take that and divide it by 18 grams. I'm going to get a number. Those numbers were 10.96 up here, roughly, and I may have rounded different than you did, and 33.33 right here. You okay with that? Now, the girls over there, they did 100, which was fine. Same answer, right? All right? Because they got 1.096 and 3.33. All right, to find mole fraction, you take the moles of what you want, which was 10.96, and you divide it by the total moles, which ended up to be 44.29. I plugged that in and got 0.247. Okay. Within a few tenths or hundredths of a decimal place, hopefully you're right on. Okay? Not too bad. All right. That, if you do it this way, that makes molality pretty easy if you do it at grams at the top. But it does make molarity kind of difficult. It just depends on which way you do it. One will be easy and one will be harder. So the molality, I already know the moles of HCl is 10.96 moles. And I need kilograms of solvent. Correct? The kilograms of solvent are given to me right here. Oh, that's ugly. But it's 0.6 kilograms of H2O. Are you okay with that? So you take 10.96, you divide it by that, and you get 18.27. That's what I got. Did someone say how or something? You two girls good on that? I don't know where you went wrong. I never could really see. Okay. Okay, that makes sense. Yes, C is where you'll apply the density. Okay. And you know what? The density could be applied to B as well. I think Hales did it now, but it still should work fine. All right. Yeah. And honestly, that probably makes more sense, but that's just not how I've ever done it. All All right, calculate the molarity of the solution. Moles per liter, right? So, in order to figure this out, I need to know how many moles there are in a liter of this substance, and now I have to use the density. So, if I have 1,000 grams of it, actually, sorry, I'm going to take 1,000 milliliters of it. I hadn't even written the grams. That sounds stupid. Don't even worry about me. Okay? I'm going to die. All right. If I take 1,000 milliliters of it, I want that because that's a liter. Worst arrow of my life. That was bad. All right. So, all right. I picked that because that makes it a liter, correct? All right. But I need to know the moles. And it's not going to just be 10.96 unless you did it the other way around. All right? So what you're going to do is take this and multiply it by your density, 1.28. And you're going to get 1280. Okay? That's the mass. And I need grams because I need to find, of this total thing, how many moles of it were HCl. Okay, so this is the mass of my liter. I'm going to multiply that mass by 0.4. How come? Because that's the percentage that is my solute. Is that 512? Right? I did this all wrong because I had the wrong number, but 512. Okay, that's grams of HCl. Now, what do you need to do to grams of HCl? Divide them by their molar mass. And that gives you a number that, once again, I didn't calculate because I had it all wrong because I wrote the wrong density. What's that number? 14.03. Point 4. I believe you. Okay. Because 40% of my mass was HCl. My total mass was 1280. So 40% is 0.4. So to find just HCl, I multiply it by that. Okay for that? Yes. Everyone that's going to say, can't you just, I'm sure you're right. Can't you just pick 1280 at the start? Yeah, remember when I started this, there's 3 or 4 ways to do it, and I even said some of them make more sense than the way I'm going to do it. So yeah, there's a bunch of different ways to find these numbers. Just depends on how you've done them in the past, how you feel about them. It's up to you. Okay, so tricky. Part D, the net ionic equation, that goes back a year. So we take HCl, we add calcium carbonate, CaCO3, and it's going to produce something. There's a good hint in E as to what, at least one thing it's going to create, is CO2 gas, correct? All right? We'll get there, yes. What? Yeah, this is like foil. It's a double replacement reaction. But there's a red flag. We'll put it together how it would make sense. You have H and CO3. So this is a -2. That's a +1. So it's H2CO3. Plus, we have Ca and Cl. This is a +2, -1, CaCl2. But my red flag forever ago said that this stuff doesn't stay this stuff. It breaks down into H2O plus CO2, and then you still have this thing, CaCl2. Okay. The net ionic equation, you have to take into account everything's solubility. This is aqueous, so it's really H plus Cl minus. All right. This was solid, so if it's solid, okay. Yeah, I didn't balance it, but we can do that right now if you want. All right. This is solid, so it stays. Goes to water, which is liquid, plus CO2, which is gas, plus chlorines are pretty much always soluble unless there was silver, lead, or mercury. So it's Ca plus 2 plus Cl minus. There's a 2 here. And then we would cross out anything that is exactly the same on both sides. And the only thing we can cross out is this. That would be your net ionic equation. Takes you back, right? Post, you okay? Plus 2 Cl minuses. Yeah, I never had balanced this up here. So since there was 2 Cl's and 2 H's, Boyd was saying there's really a 2 right here, which puts a 2 here, a 2 here. So, okay, that was awesome. I love net ionics. Don't you love how this class can test you on something you learned 4 months ago, 5 months ago? As long as we go over it today. All right. Now, E tests you something you learned just 2 weeks ago, so that should be easy, right? All right. Did anyone do E? Hey, nice job. I don't know the answer. So let's do it together. It might take a little while. 28 grams of calcium carbonate were to react with 200 milliliters of the above solution. All right. So the first thing you have to do is find out which is your limiting reactant. Caitlin, smile. Thank you. All right. I don't. Has anyone ever watched the movie Glory? And that is a P, right? So I'm not being a butthole. I'm just trying to make you ready for the hardest test you'll ever take. All right. So I got to convert both of these to moles, correct? What was the molarity? 14.03, right? That's important. So we take 28 grams and we divide it by the molar mass of CaCO3, which is 90 or 100? 100. All right. Okay? And you just get 0.28, right? Okay? And then this one, you have to take your liters and multiply it by your molarity. So you have 0.2 liters, and you're going to multiply it by 14.03 moles per 1 liter, and you get 2.806. Is that right? What did you get? Now, when we wrote this out, there was a 2 in front of HCl, right? All right. This is my HCl value in moles, correct? This is my calcium carbonate. Good so far. This had a 2 in front of it. This had a 1 in front of it. Do you know where the 2 and the 1 came from? From the balanced chemical equation. So you then ask yourself this. Is this number at least 2 times bigger than that number? Yes. So which one is your limiting reactant? This is your limiting reactant. Okay? So now we're ready to roll. It was harder? It was all grams and grams, which is a lot harder. And the coefficients were a lot different. It was like a 3, a 4, and a 3 and a 2. Like it was more complicated. But we teach you harder than you normally need so that it's easier eventually. Okay, so now all I need to do is take my limiting reactant moles and convert it to moles of CO2, right? Which is really what in Piv Nerd? N. Once I get N, life is so much better. Okay, so there was a 1 in front of calcium carbonate, right? What was in front of CO2? We never wrote it out, but it was also just a 1. Okay? So, N is 0.28. That's your N value, and now we got to Piv Nerd the whole thing. So just remember 0.28. Can I erase all this? Is that okay? Okay, so N equals 0.28. I am solving for how many liters, so volume. If PV equals nRT, then V equals nRT over P. So I'm ready to go. V equals 0.28, R 0.0821, T was 300, and my pressure is 1. Did you do it right, girl?
We didn't do any of that 200 times NP. We just took 20 grams.
Well, you got lucky then, because that was your limiting reactant. But good. All right. And what did you end up with? 6.89. 6.89?
Well, 6.9.
Okay. Okay.
Okay, Isaac. Okay.
All right. Ever since I told Caitlin that she's my barometer, she won't make eye contact with me. All right. How fun was that, for freak's sakes? Like, it wasn't weird. It was necessary. Now, these girls got it right, and I'm super proud of them. They're like, no, it wasn't. But if this ended up to be your limiting reactant, then you would have been wrong, right? You always got to double check what is going to determine how much I make. And they just started with 28 and they rocked it, and I am proud of them. But double check the limiting reactant next time. Okay, Sam? Oh, sorry, checking your watch. Okay, there is one bonus question on this test. Yeah, there is one on the internet. The bonus question looks like that. It's not hard at all. Ethanol normally boils at that. The boiling point elevation constant for ethanol is 1.22. What is the boiling point of a solution of 150 grams in 750 milliliters of ethanol? The density of ethanol is this. Don't panic. You have to use an equation that will be written on the board that says you take this number and multiply it by the molality of the solution. The molality is moles of ethanol. Where is that? It's moles of calcium chloride. 750 milliliters. The density, so you got to multiply this. And then you have your moles. Then you have your grams, which you should convert to kilograms. Divide them, multiply them, and add them. It's a bonus question. I did.
Oh, good.
There's homework problems just like it. The sample problem, we did one just like it. It's a little bit harder because it already gave you the molal. You have to calculate molal. Yes, Sammy G. Yeah, I cut this from the test. I'm going to change the numbers, and I'm going to change the stuff. So it's not going to be HCl. So basically, know your shiz.